Okay, guys. So this is video 2 of section 14.4. We're talking about factoring trinomials ax squared plus bx plus c, the one when a it's not equal to 1 using AC method. So I'm going to start with example 4, factoring polynomials with degree higher than 2. So that means you're going to have the example when the exponent it's going to be higher than 2. So let's start with A. We're going to do a couple examples like this. You have 10x to the third power minus 85 10x to the third power minus 85 x squared plus 105x. So like you see in this case, the degree of the polynomial, so let me just write down degree of polynomial. Done. Polynomial is 3. Okay, so this is the highest exponent. Exponent in the equation. So that's what is the degree of polynomial. Okay, so what we will need to do with the problems like that, you will need to factor out GCF in order to get the remaining factor in form ax squared plus bx plus c. So step 1, you need to factor out greatest common factor, because we don't know how to factor this one. Okay, we want to get into that quadratic type equation. So you need to factor GCF first. Okay, so always when you have negatives or in front of x squared or variable to the exponent higher than 2, you're factoring out GCF. So what is the GCF? Okay, so we have 10x to the third minus 85x squared plus 105x. So you need to find that GCF. Okay, so let's find the GCF between the integers which we have. You have 10, 85, 105. So think about the number which can divide all of them, and the biggest number will be 5. Okay, 5 can divide 10, 5 can divide 85, 5 can divide 105. Next, find the GCF when we're comparing variables. So you have x to the third, x squared, and x. So we talk about those examples. So then it's going to be your variable to the lowest exponent, which is x. So our GCF is 5x. So we're going to factor that GCF. So we're getting 5x times, and let's take care of the rest. So take your original expression, which was 10x to the third, and divide by GCF, which is 5x, and that will just give you 2x squared, and that 2x squared will be in the parenthesis. Then take the next expression, which is negative 85x squared, divide that by your GCF, which is 5x, and we will end up with negative 85 divided by 5 will give you negative 17, x squared divided by x, that's just x. So negative 17x will be in the parenthesis. And one more time, take your third expression, which is 105x, divide that by GCF, which is 5x. Okay, 105 divided by 5 will give you 21, and x divided by x is 1. So we'll just have 21, and that 21 will be in the parenthesis. Okay, so let's just rewrite that. So our original equation, 10x cubed minus 85x squared plus 105x, it's equal GCF, which is 5x. Okay, that's our GCF. You always have to keep it. Okay, that's the one which we keep it. Okay, we cannot ignore that. Times, and let me rewrite that quadratic equation. 2x squared minus 17x plus 21. Okay, so guess what? What we doing next? Next, we need to factor the trinomial which you have in the parentheses using AC method. So step 2, factor out 2x squared minus 17x plus 21 using AC method. So A is equal to, B is equal negative 17, C is equal 21. Okay, so first we multiply A times C. We're getting 2 times 21, which is 42. Then we looking for two integers, which by multiplication will give you 42. Okay, which is AC. And the same two integers by addition will give you B, which is negative 17. That's our B. Okay, so we have to check and see what's going to work. Negative 14 and negative 3 definitely works. Okay, so that's the part which sometimes take the longest to find those two integers which satisfy those two conditions. When you have it, the rest becomes smooth. Okay, so next, create two factors, ax plus first integer, which in our case it's negative 14, times ax plus second integer, which is negative 3. Okay, so in our case we have, again going back, a is equal to, so we're going to have 2x plus negative 14 times 2x plus negative 3, and again simplify. When you have plus and minus, just rewrite as minus. So 2x minus 14 times 2x minus 3. Okay, again, not a final answer. This is not a final answer. Don't forget that when you create those two parentheses, you need to factor GCF from each parenthesis and ignore that GCF. So next, factor out. Come on. Okay, next what I want you to do, factor out GCF from each parenthesis from each parenthesis from each parenthesis and ignore it. Okay, so let's do that with 2x minus 14. The GCF here, it's equal to, so we can rewrite that as 2 times x minus 7. Okay, Um, Next, you have 2x minus 3. The GCF is equal 1. So rewrite that as original, which is 2x minus 3. So in this algorithm, when you have those two groups and you find the GCF, don't forget that we ignoring that GCF, okay? So we skip it, ignore it. So what we're going to do, we find our two factors. So our two factors will be 2x minus 3 and x minus 7 only. Okay, so rewrite parentheses without GCF, which we ignore. So we have x minus 7 times 2x minus 3. Okay, that's what we're going to keep it. And step 3. So keep it. Step 3. Don't forget that original problem had the polynomial of degree higher than 2. So you need to rewrite the original polynomial, which was 10x to the third power minus 85x squared plus 105x using GCF from step 1. That was that first one. And x minus 7 times 2x minus 3. Okay, so going back to the step 1, okay, right here, our GCF was equal 5x. So don't forget that we need to keep that 5x. Okay, so let's rewrite that as 5x. So again, 10x cubed minus 85x squared plus 105x, it's equal 5x. That was that GCF, the first original GCF. Okay, we'll put original GCF times and the factors which we just find it, x minus 7 times 2x minus 3. And that's our final answers. We have all the factors. That's the final answer. Okay. Okay. Let's do more. I have 2 more examples to practice. Example B. We need to, again, factor 9y to the third power minus 30y squared plus 24y. So the same idea, degree is higher than 2. So you need to factor out GCF first. Okay, just remember. Okay, so let's do it. So first step, factor out GCF of 9y to the third power minus 30y squared plus 24y. Okay, So what will be the GCF? So let's find our GCF. You have 9, 30, and 24. Find the integer, the greatest integer which can divide 9, 30, and 24. That will be 3. And then we have y to the third, y squared, and y. So when you have variables, the same variables, you pick the one with the lowest exponent. So it's 3y. That's the GCF. So we're going to rewrite that as 3y, okay, times, and let's show work how we're going to find the expression which goes inside the parenthesis. So take the first expression, which is 9y to the third power, and divide that by GCF, which is 3y. 9 divided by 3 will give you 3. Y to the third power divided by y will give you y squared. So that goes inside 3y squared. Then you take negative 30y squared, divide by GCF, which is 3y, and that will give you negative 30 divided by 3 is equal to negative 10. Y squared divided by y will give you y. That goes right here, minus 10y. And take the last expression, which is positive 24y. Divide that by GCF, which is 3y. And we end up with 24 divided by 3, which is 8. Y will cancel, so just putting 8 in the parenthesis plus 8. Okay, so we have it. Second, we're going to factor out our expression from parenthesis, which is 3y squared minus 10y plus 8. That's a trinomial using AC method. So like you see, I'm only using one method to complete all those problems. So hopefully by now we know all the steps how to factor a trinomial using AC method. And of course, to use AC method, the trinomial has to have a degree too. So your exponent has to be 2. Okay, so A is equal 3, B is equal negative 10, C is equal 8. So step 1, we multiply A times C. So we're getting 3 times 8, which is 24. Then next, we're looking for 2 integers, which by multiplication gives you AC, which is 24. And the same 2 integers by addition has to give you B. And in our case, B is equal to negative 10. Okay, so we need to check what's going to work. Negative 6 and negative 4 will work. So negative 6 times negative 4 is equal to positive 24. Negative 6 plus negative 4 will give you negative 10. Okay, so next what we're going to do, create a y plus first integer times a y plus second integer. Okay, so that's what we're doing next. Okay, don't forget that in our case a is equal to 3. Okay, so we're having 3y plus first integer plus negative 6, which you can just put it as negative 6 times 3y plus the second integer, which is negative 4, so you can just put it as negative 4. Okay, so again, this is not a final answer. It's is not the final answer, okay? Don't forget that when you create those two factors, you need to factor out the GCF from each group, okay? So next, factor out GCF from each parenthesis. Super important. So take that 3y minus 6, GCF here, it's equal to 3. So we're going to factor 3 out. 3y divided by 3 will give you y. Negative 6 divided by 3 will give you 2. Okay. Okay. And ignore GCF equal 3. So ignore that. And keep only parenthesis, which is y minus 2. Okay. I'm going to do the same thing with the second parenthesis, which is 3y minus 4. GCF here is equal 1, so keep 3y minus 4. So when GCF of the parenthesis is equal 1, you keep your original parenthesis. So keep that 3y minus 4. Okay. Next, we're going to rewrite that with our final factors. Okay. Okay. So we're going to rewrite it as y minus 2 times 3y minus 4. Okay. Okay, and the last one. Rewrite the original equation. Rewrite the original equation, which was 9y to the third power minus 30y squared plus 24y, using original GCF from step 1 and factors y minus 2 times 3y minus 4. Okay, so let's just rewrite that. So right here we have 9y to the third power minus 30y squared plus 24y. Let's go back to step 1. Okay. The original GCF was 3y, so we need to keep that 3y. Okay. You have to keep it that original GCF. Times and those two, y minus 2 y minus 2 times 3y minus 4. Come on. 3. Okay. Not sure why it doesn't allow me to put it here. Original GCF, so let's just put it. So which was 3y times y minus 2 times 3y minus 4. That was the original GCF. Okay, so that's it. That was the last example from section 14.4. Okay, and you're going to see probably in the next 1 hour the remaining section with you're going to see the videos with section 14.3. Okay.